Hey guys, I'm Brian Mann, and you're watching the second episode of BackboneRails. We're going to be covering a day in the life working with Backbone.js and highlight and expose its strengths and weaknesses. Backbone is indisputably wildly successful. You wouldn't guess that by glancing at its documentation online, but scroll down to the number of companies that have utilized Backbone and you'll see some major players. Backbone has had innumerable plugins, extensions, articles, tutorials, and books already written for it. So what makes Backbone so popular? Backbone, as we discussed in episode 1, is centered around model-driven development. It's extremely appealing in that it's very small and lightweight, coming in at just under 6 kilobytes gzipped. This makes Backbone highly digestible for new developers. Along with it being small, it's built with very little opinions about how you should go about developing with it. This makes it really customizable and flexible, and it doesn't hinder you from being creative, nor does it try to cramp a specific development style on you. So what this means is that Backbone has a really low barrier to entry. You can pick it up and start working with it immediately. So let's take a peek into the core Backbone components, what they give us, and what they do. Let's assume we're going to be building a simple use case here, where we want to display a list of users. We'd have some basic HTML markup here, outlining our table, which ends up looking like this. And for this feature, we'll want to fetch a collection of users from the server, and when the results come back, insert each user model as a row into the table's t-body. So it'll look like this. We'll also want this page to be routable. That is, we should be able to navigate directly to this page and be able to bookmark it. So to make this happen, the first component we'll need is, of course, a router, which is where we'll start. With Backbone being written in an object-oriented fashion, we'd begin with an instantiated router and ensure Backbone is monitoring the URL. Then, with our router listening to hash change events, we then navigate to hashtag users. Backbone receives and parses the client-side part of the URL, which is matched against the routes object literal, and calls the method listUsers. Typically, our router is also responsible for managing collections or models, and in our case, since we want to fetch a collection of users, we'll instantiate our users collection here, and call the fetch method, which makes an AJAX request to the server for those users. The router also conventionally wires up the view. So we'll instantiate a view and pass our users instance as the collection property. And then finally, it's up to us using, say, jQuery to then manually push this view's template into the DOM, else nothing would display on the screen. So notice here we're deciding that this view should go into the element with an ID of users, and we're passing it HTML content by calling the render method on the view. So the responsibilities of this render method would be to obviously return HTML content, which we'll get to in a second. So now we're going to take a peek at this view that we just instantiated from our router. Notice here I'm calling this a collection view, but don't be confused. This is just extending from Backbone's view. It has no special properties or methods. It's like any other Backbone view. I'm referring to it as a collection view due to its responsibilities, which since it was passed in a collection, it needs to manage that collection. This will make a little bit more sense later on. So like all Backbone views, this needs to have a template property, which generates the actual HTML. This collection view's template was the HTML structure we showed initially, which set up the initial scaffold for the table with the empty t-body. We of course need to handle this collection's events, so here we're saying when the collection fires its reset event, which happens after the server responds to the fetch, to call the addAll method. addAll then iterates through each model in the collection, calling add1, which instantiates children item views for each model. Also notice here we have to decide in the same way we did in the router where in the DOM these new views will be inserted into, and also the method by which they are inserted. So in our case, since we want these models to display as a row, one after another, we need to ensure that we're calling jQuery's append method, which naturally appends each to the t-body. We decided where they end up going, but like in our router, we still have to tell them to actually render, so they return their HTML content. So lastly, you can also see our collection view's implementation of the render method. When we called the render method from the router, this is what was executed. We accessed our HTML template, passed in our collection as JSON, which controls which properties the template has access to, and then we returned it along with the view instance itself. So now let's take a peek at one of those item views that this collection view instantiated. So here's our item view. Like our collection view, we're just extended from Backbone view here, so when I say item view, I'm referring to the responsibilities of this view, in that it's only responsible for managing its past end model, one item. Like our collection view, each item view has its own template. We also set a tag name which tells Backbone what element our primary L will be. Since we need these to be table rows within the table body, we need to set this to a TR. We also need to set up our primary bindings, the same way we did previously in our collection view. However, this time it's to a past end model. Here we're going to wire up to our model's destroy event. So whenever that destroy event fires, the remove this method will get called. The remove this method will end up removing our L from the DOM entirely, thus ensuring the row visually disappears. We also have this events object literal here, where we can wire up to events that the DOM itself emits. Here we're saying when the click event is fired on the anchor link with a class of destroy, to call the destroy method within this item view. The destroy method has to implement actually destroying our model, which will in turn cause the model to fire its destroy event, which then ensures the view is destroyed. This seems like quite a bit of code, but we're essentially wiring up two different things. One is for giving our template the ability to listen to DOM events and destroy the model, but the more subtle thing we're doing here is ensuring that regardless of how our model is destroyed, whenever it is destroyed, this view will know how to detach itself from the DOM. The destroy event could come from another source. Thus, we're building this flexibly to ensure regardless of how or who destroys this model, that whenever it is, this view cleans itself up. So finally, we still have to implement our render method again down here, which looks strikingly similar to the way we did it in the collection view. So moving on, we'll look under the hood at what's going on within our actual templates. You've seen that each Backbone view has a template property that corresponds to a specific template file, kind of like how you would do it with server-side templates. And this is the template our item view was using. And as you can see, it has the ability to access the model properties. So our table row would have 4 columns displaying the user ID, the first name, last name, and of course the destroyed link that we just talked about. And this should look really familiar if you've ever worked with server-side templates. We're essentially interpolating variables, in our case properties of the model, but this is obviously what creates the dynamic nature of templates. I should also note that this is just one templating solution called Eco. Eco stands for Embedded CoffeeScript, and it's what gives us the ability to write Ruby ERB-like syntax with support for also writing CoffeeScript in line. There are, of course, other popular options like handlebars, mustache, or just basic underscore templates. Each has their own differences and feature sets, but ultimately all work the same way. We'll get to this in later episodes, but with our server-side setup, you'll see all of our Eco templates are precompiled when going into production, which is the ideal scenario for performance. And though it may not be 100% clear now, you'll see a really nice pattern for working with templates with folder and file naming conventions in later episodes. And lastly, of course, we have Backbone collections and models, which are at the heart of every application. These guys are really easy to configure and add methods to. You can see I've defined a method called full name here, which would return the model's first and last name concatenated together. And this method would naturally be available to be called from your templates or anywhere else you have a handle to the model instance. Wiring up collections to models is also as simple as passing in the model property, which references the model's class. When we originally fetched these users, Backbone knew the server endpoint to call, that being /users, because we defined the URL property here. Models and collections are special in that they emit different events throughout their lifecycle. Collections fire a reset event whenever they're returned from the server, which is what we binded to in our collection view, and it's what added each of the item view instances. Models and collections introduce a crucially important concept when building scalable JavaScript applications. By building your applications in an event-driven nature, we can ensure the components of our applications are decoupled from one another. That is, we can have independently functioning parts that publish events, and other parts who are interested in those events can listen and subscribe to when they happen. Concerns can then start splitting out and rules begin to materialize, all of which we'll be covering in detail. So this is a diagram of the previous workflow we just created. We went through instantiating our router, which listened for hash change events, matched the client-side route, and kicked off everything. It instantiated our initial users collection and told us to fetch the users from the server. And then with a handle to that user's instance, we created our initial parent collection view, passing in the users collection. And we told the collection view to render into the DOM. Our collection view had its own template, responsible for setting up the initial HTML for the table and the empty t-body. Our collection view was also wired up to the reset event, so when the results were returned by the server as JSON, the collection view fired the reset event, and we iterated through each of the models, creating new item view instances per user and passing the model into each of those item views. Our collection view also decided where these item view instances were inserted into, which in our case we told each new item view to append itself to the collection view's t-body. So this is a pretty standard Backbone workflow when you're working with collections, though I'm sure you'd get slightly different implementations between developers since Backbone has no opinions about application workflow. Nevertheless, even with our really basic feature, we've pretty much covered every component Backbone offers us. This is literally it. It's pretty simple, eh? Definitely helps promote the notion of Backbone having a low entry level. But seriously, how could that be it? There are so many unanswered questions. What about navigating to different routable pages and handling page transitions? What happens to the old views that get left around? How do you change application state? What about nested collections and resources? How could you approach developing the complex applications we saw in episode 1 with only these simple structures? Turns out building scalable applications in JavaScript has considerably more architectural layers we need to implement. With that said though, if you're just looking at embedding some functionality like a widget with Backbone, this is probably all you should need. Dashboards are a really common example of this with analytic-like features or some charts. Really, any task that's using a single router, or even none at all, should be no problem to develop with just the components that Backbone gives us. What I'm getting at is that Backbone really only offers us a small set of building blocks. It's enough to develop basic single-page applications, and maybe a little bit more if you're clever. Think of Backbone's toolset like a hammer, a saw, and some nails. If you're building a birdhouse, that's all you'll probably need. But honestly, there are a lot of missing pieces if you're trying to build a fully featured application. So what's missing? For starters, this little guy known as application infrastructure is totally absent. Backbone has no notion of modules, sub-applications, no messaging bus for the components to communicate with other than through model and collection events, and there's little to no encapsulation of responsibilities of components other than what we choose to implement and enforce as the developer. Surprisingly, as much as we talked MVC in the last episode, you'll notice we never once said the word controller in Backbone. It's suspiciously missing. Without this infrastructure, we're going to have an extremely difficult time scaling our application. But there's also more hurdles to trip over. Backbone is riddled with excess boilerplate because of its small set of components. Because we only get routers, views, models, and collections, you'll be writing the same code over and over again, and implementation will be very wet. We already wrote 4 render implementations just to get each view to insert into the DOM, from the router to the collection view, and from the collection view to the item views. We'll also be wiring up everything manually every time. Whenever we create a nested view hierarchy, you'll see those same add all and add one methods in every collection view. You'll also be wiring views up to the same collection and model events constantly. At the heart of it, there's just not enough separation between each component's responsibilities. Models and collections by themselves are well vetted, but everything else has a tendency to become a tangled mess. As I mentioned, there's no notion of controller, so your router ends up with a dual role, acting like both. When we get into real applications, there are an enormous amount of subtleties of how you want to handle your view's business logic related to the DOM. When should we hide something, show something, remove something, add something here, move it around there, drag and drop somewhere else, show error messages, prompt for input, all kinds of things. So that manifests itself by having massively packed view methods. I've seen render methods with over 100 lines of them, all just trying to get the DOM situated in a certain position in order for things to look correct to the user. So as you might imagine, when Backbone apps start to get complicated, codebases have a strong propensity to become totally unmanageable. But there is one final nail in the coffin. Whenever we are building stateful applications, the arduous task of managing object references comes into play. Unless we manage them correctly, we can easily create zombie objects, that is, objects that are never garbage collected by JavaScript. They'll stick around forever, eating up memory. JavaScript is a sweep and destroy language, and we have to have a firm understanding of the way this works to not shoot ourselves in the foot. JavaScript has always been this way from day one, but we weren't privy to having to worry about it as much because memory is automatically released whenever a full page refresh happens. So up until we started developing fully single-page applications, zombies would just naturally be purged whenever you clicked any link. So how does this happen, what does it do, and how do we prevent it? It happens when objects hold a reference to each other, like when we're binding objects to an event. Inside of our view here, when we call the .on method on the model property, we are handing a reference to the object we're binding to. So our model is being handed a reference to this view's method, and thus the view instance. And if we ask ourselves, is this reference, the view instance, supposed to be garbage collected? In this case, the answer is yes. This is a view instance, which we want to be cleaned up whenever we don't need to visually see it in the DOM. But what we've just done by having this model hold a reference to our view instance is prevent this view from being garbage collected until the model is also garbage collected. This means not only does this view stick around in memory, but the objects that are referencing it are still holding a reference to it, which creates the strong possibility of causing all kinds of visual bugs and problems. If you've worked with Backbone, you've no doubt come across this, as the demo to-do apps and tons of tutorials online are wrought with zombie memory leaks. Here's a scenario. You've just created a model, and you pass that model into a view. Then, inside that view, you wire up to the model events like we did in our initialize method. Then say you visit another route and you tell that previous view instance to go ahead and close and remove itself by calling that method directly here. Then we'll end up creating another view instance, passing in that same model again. Now you'd expect that our first view instance, represented by the v variable, to have been garbage collected, right? But the answer is no. What you've just created is, in fact, a zombie view. The first view was never actually cleaned up, and thus when your model event fires, in this case when foo changes, it'll fire multiple times for each view it's still referencing, which at this point would be the two view instances, v and v2. If you're logging out to the console, you might have been confused seeing more and more events firing as more references get created, and that, my friend, is a memory leak. To prevent this from happening, we have to be certain to unbind these events, so instances can be garbage collected. But this ends up creating a lot more code for each bound event, so to really do this correctly, we'll need a way to abstract automatically unbinding these events. Let me just say that I want to preface everything we just talked about. Back when I started writing this episode, in fact, since Backbone was released on day 1, zombies have always been a systemic problem. But Backbone did recently update to 0.9.9 only a couple of weeks ago as of releasing this video. And in that latest update, they did add several methods which facilitate automatic binding and unbinding for views. So this problem doesn't permeate as much as it has in the past. However, I still kept this slide in for the video to hopefully help explain the ramifications of the problem, because not only can it happen in regular JavaScript applications, but you can still accidentally cause the issue while building Backbone apps, though causing it to happen within your views is more difficult now. It's something as developers we should be familiar with and comfortable solving. So how could all of these problems with Backbone exist and yet it still be one of the leading frameworks? Either I've got to be crazy, just plain wrong, or I'm missing something. Well, to Backbone's defense, it's not supposed to manage any of the things we just talked about. Remember, after all, that's part of what makes it appealing. It's not opinionated about workflow, application structure, or really going about most things. That means it's up to you, the developer, to facilitate these things. It's up to you to develop systems for handling page transitions and cleaning up old references and objects. That's why Backbone is so ridiculously small, and that's why the barrier to entry is so low. The problem is that these are still difficult problems that have to be solved in order to build decent-sized applications, so it leaves a lot on your shoulders to manage. And as beginners or even intermediates, this is really overwhelming and frustrating. So what is the solution then? Well, it turns out there are quite a few popular solutions, and I'm going to introduce you to one of the flagship frameworks out there. It's known as Marionette.js, a composite application framework which helps you build scalable Backbone applications. Marionette is a full-stack framework built specifically for Backbone. It doesn't seek to change Backbone. Models and collections stay the same, but it's going to add a tremendous amount of functionality to Backbone, which makes working with it a pleasure, and it'll take care of the heavy lifting behind the scenes for you. Composite here is the important keyword. Marionette in itself is comprised of independently functioning parts. You can choose to use any number of Marionette components. You're not forced to use all of them. Integrating Marionette instantly makes your applications much more modular with its messaging bus architecture. This is how each of the Marionette components will be able to communicate with each other through publishing and subscribing to application events. As you've already seen from working with vanilla Backbone views, there's a tremendous amount of boilerplate, and Marionette is going to eliminate that with specialized view types, which we'll be covering in detail in the next episode. And even though Backbone recently patched its views with zombie management methods, Marionette has had this solution since day one. When dealing with complex application interfaces, you'll also be needing support for specific layouts and regions, which make inserting views and removing views a simple process, which we can extend tremendously in order to create smooth transition states, drastically improving the user experience. So here's a visual representation of the differences in stacks from what you'd get with working with Backbone by itself and what Marionette is adding. We'll be going into detail about each one of these layers in the next episode and show how each one fits together. Because Marionette adds specific components, each with their own set of responsibilities, it gives us an excellent blueprint for when we need to make modifications or add our own specific behavior to these components, which helps keep your application scalable and organized. In episode 3, we'll be revisiting our example feature. We'll go through each of Marionette's components, showing you how they interact and dramatically improve your application's workflow.